In this video, we're going to be learning about rational numbers and irrational numbers. Throughout this video, we're going to be covering the following topics. First, we're going to look over what a rational number is. Second, we're going to look at some examples of rational numbers. Third, we will look at what decimal rational numbers are, especially terminating and reoccurring decimal rational numbers. Fourth, we're going to look at what irrational numbers are. Fifth, we will look at some examples of irrational numbers. Sixth, we'll look at some famous irrational numbers. And finally, seventh, we're going to be working with irrational numbers and rational numbers with coding in Python. So let's get started with what a rational number is. So a rational number is a number that can be represented as the ratio of two numbers, such as a or b. And also, a and b both have to be integers and b cannot be 0. So here are some examples of rational numbers. So an easy one is the number 1, and we know this because it can be represented as 1 over 1, or negative 2 over negative 2, or 1,000 divided by 1,000, and they all equal to 1. So basically, if it can be written as a ratio format, then it is a rational number. Some other examples could be negative 4, so we could do negative 4 divided by 1, or 4 divided by negative 1, or negative 8 divided by 2. And one more example could be, for example, 16, so 16 divided by 1, negative 16 divided by negative 1. So those are just some examples of rational numbers. So now let's go over what decimal rational numbers are. So a decimal rational number can be either terminating or non-terminating reoccurring. So let's first take an example to clear our minds. So let's take the number 3.75. So we know that this is a rational number because we can do 15 divided by 4, which gives us 3.75. So 3.75 would be a terminating rational number because it ends at a fixed point. We have an ending number after the decimal. So since we have 0.75 at the end, it stops. So that's what terminating means. So a non-terminating rational number would basically be a number that keeps on repeating itself and keeps on going. So for example, if we have 1 divided by 3, if we have 1 divided by 3, it goes as 0.33333. So it keeps reoccurring and it keeps on repeating itself, and it doesn't terminate, so it keeps on going. And that number is still a rational number because it can still be written as the ratio of 1 over 3. So some more examples of decimal rational numbers could be 5 over 2, and we know that that equals to 2.5, which is also terminating. And we can do 17 over 5, and that is 3.4, which is also terminating. And we could also do 8 over 15, which is 0.53333. So that is non-terminating reoccurring. And one interesting one is 11 over 21, and that equals to 0.5238009, and then it keeps on repeating itself. So this is also a non-terminating reoccurring because even though it's different numbers, it keeps on repeating the same thing after a few digits. So sometimes you have to check after a few digits to see if it is non-terminating reoccurring. So now let's go over what irrational numbers are. So an irrational number is a number that cannot be written as a fractional form. So for example, the value of pi. The closest that we can get to the exact value of pi is 22 over 7, but even that, it still ends at a certain point. But we know that pi keeps on going, so that is an irrational number because there is no ratio for it. So now what are some famous irrational numbers? So the most famous ones are either pi or e, the golden ratio, and basically many square roots. So we know that pi already, as we had an example before, it goes 3.1459 and so on. And it never repeats itself, it never stops, so we know that it is an irrational number. And for the number e, it is 2.7182 and so on. And this one also doesn't ever stop or repeat. And the golden ratio as well is 1.618 and so on. And that one also doesn't repeat. And also many square roots such as the square root of 3, the square root of 99, the square root of 2, they're all irrational numbers. So now that we know what irrational numbers are and rational numbers are, and we know the examples of them, now let's move on to our coding part where we're going to be looking at some Python programs to find out irrational numbers and rational numbers. So I have a few different codes for both of the irrational numbers and rational numbers, but we're first going to start with rational number and coding in Python. So this is the first code that I've got for the rational numbers, and it's very simple. Mostly anyone can do it. It's basically we're going to ask the user to import any number for the numerator, and any number for the denominator, and we're just going to divide them to get our decimal number. So we're basically just converting the fraction into a decimal. So we can just quickly run this to see what happens. So if we open this up here, so enter a numerator number. So if we just for example, let's do 2, and then enter a denominator, and if we enter this, then we get 0.5. So this is basically just a simple code that helps you to convert from fraction to basically a decimal. So our second code is technically the same thing, except we're adding one line which helps us to format our decimal. So basically this will help us to let us choose how much decimal points that we want. So if we want 10 decimal points, then we can add 10. If we want only 2, then we can add 2. And if we want 15, we can add 15, and so on. So we have the same code in the top and bottom, so for the numerator, denominator, and then divide that. And then here, we're going to create a new variable called DEC, or decimal. This stands short for decimal. And here we're going to format this. This is going to help us to actually format our decimal points. And then we're going to format our decimal number that we get from up here. And we're just going to print DEC instead of decimal here. So now if we run this, so as of right now we have a decimal point set to 10. So if we put 22/7, which is the value, well, close to the value of pi, then we get 10 decimal points after the decimal. So we have 3, 6, 9, 10. So this basically helps us for that. So now if we just put maybe, for example, 4, and if we run this now, 22/7, yeah, then we only get 4 decimal points. And you can keep on experimenting with this just like the other one. So this is basically just a simple code that helps us to format our decimals. So now that we're done with our rational number coding, let's move on to our irrational number coding with Python. So here I have all the code for the irrational number. So just before we jump into running the code, I'm just going to explain a few things about what we're going to be doing today. So basically today, we're going to be working to find out the value of pi. So to find pi, assume a circle of radius r. Now divide the circle in 6 segments as shown in the figure. In this case, we have the length of segment, which is equal to length, and the letter n, which is equal to 6. With this, estimating the area will not be accurate because we are not getting the value of 3.14. So to get the accurate value, we're going to need to increase n, which is the number of sides. And we can increase it to at least about 60,000. And as we increase the number higher and higher, then we're going to get closer and closer to 3.14. So that's basically what we're going to be doing with our code today. So as you can see here, if we skip down here for a second, we're just increasing this value to get closer to 3.14. So I'll just quickly explain what this code does here. So we're first importing a library called math, and now here we're going to be defining a function called estimate_pi, and we're going to pass in the values of length and n. So for the radius, we're going to write radius is equal to the float of length divided by math square root 2 minus 2 times the math cos with math radius of 360 divided by n. And here we're going to be making our diameter, and the diameter is obviously 2 times radius, and our circumference is going to be the length times n as we pass the values up here. And then we're just going to be returning the float of the circumference divided by the diameter. And then here we're going to be printing out our estimate of pi, and so here we're going to have 1, 60,000, and we're just going to be changing this number back here to get our actual value. So if we just leave this at 6 right now, that means we're going to have 6 sides on our shape inside of our circle. So if we have 6 sides, this will be inaccurate to the value of pi. So if we just run this quickly and open this up here, we get 2.999, and this is not even close to the value of pi. We know that is 3.14 and so on. So to change this, we got to go higher and higher. So now let's just move up to 1000 instead of 6. So now we should get closer and closer to the value of pi. So now we do get 3.14158.7, but we know the actual value is 3.14159, but we are getting really close. So just after this is a bit incorrect. So if we bump this up to maybe 10,000 now, we should see a 9 come up after here. Yep, and now we got 9, and we are getting very close to the real value of pi. So if we just hit this at 60,000, then this will be very accurate to the value of pi. So this is very close to the real value of pi. We know the real value is 3.1459265, and we are very close to that. It's just that after this number it gets a little incorrect. So basically this is just trying to show the more sides that you add, the more closer it becomes to becoming a real circle. Because having 60,000 sides inside of a circle, that will get it really close to the edge and it'll almost make it look like a perfect circle. So that's basically the code for our irrational number for finding the value of pi. And also that will be the conclusion of this video. If you guys enjoyed this video, make sure to like and subscribe because it does take some time to make these videos. And we'll see you guys next time.